So students, today we'll start that is ammonia. So ammonia was initially called alkaline air. Ammonia was initially called, why it is alkaline air? Because ammonia actually dissolves in large quantities in what you can say water. You will come to know later on. Joseph Presley, for the first time in 1774, nearly, that is 1774 or 75 nearly. Okay, so Joseph Presley, for the first time, he prepared ammonia by heating slaked lime with sal ammoniac. Alright, slaked lime means calcium hydroxide. Alright, and sal ammoniac is nothing but ammonium chloride. Now, he called this gas as an alkaline air. He only called it because it is highly, what you can say, it was basic in nature. This particular gas was. Next, Berthollet, another scientist, he studied the chemical composition of the gas. He studied, and later on Davy confirmed that ammonia consists of nitrogen and hydrogen. It is consisting of nitrogen and hydrogen. It's made up of nitrogen and hydrogen. So starting from Priestley, then Berthollet, then we are having Davy. We can say that. Now ammonia occurs in the free as well as in the combined state. In the free state, we are getting the atmospheric air, and in water also little bit amount of ammonia is being there. Ammonia is also produced when nitrogenous matter decays, we can say that, in the absence of air, which is otherwise known as nitrogen fixation. We can say that particular process, and it is being done, you have read in biology, that is nothing but it is being done by putrefying bacteria or the ammonifying bacteria. Alright, it is being done. Clear. So in this way, this particular process, by this process ammonia is being added to the air, we can say, in the atmosphere. Okay, it's also being added by nitrogenous organic matter like urine and all. It is being added. Alright, when you are urinating, it goes to the soil and it is being added, ammonia, into the air, we can say. Now in the combined state, ammonia is being present in different ammonium compounds. Like ammonium salts are there, like ammonium chloride, ammonium nitrate, ammonium sulfate, and so on. And also we are having the ammoniacal liquor. Ammoniacal liquor, you know, that is ammonium, nothing but hydroxide, we can say that. Clear. Sal ammoniac is ammonium chloride. Okay, so in this way, so this is the just a basic information about ammonia, I said it. Now we'll come to the preparation of ammonia. Generally in the lab, we prepare ammonia by the salt of ammonia and alkali. Ammonium salt is ammonium sulfate, ammonium chloride, but not ammonium nitrate, mind it. Ammonium nitrate, never we take it for the preparation. Why? You note it down, this one. Ammonium nitrate is not taken because it is explosive in nature. Ammonium nitrate, alright, it is highly explosive in nature, and it decomposes. Definitely, when the one which is explosive, it decomposes very easily. Alright, it's not stable, it's unstable in nature. For that reason, never we take ammonium nitrate. Alright, so the points which I am saying, always I say, whenever you listen to my AV, when you are looking at my AV, you take a pen and copy and write down what I am saying you. Alright, so ammonium nitrate is unstable, it is highly explosive in nature. For that reason, it's never preferred. We are taking ammonium sulfate or ammonium chloride. Along with that, we take an alkali. Alright, or we can take any base. Like in the first equation, you can see that when ammonium sulfate reacts with NaOH, it gives what? Sodium sulfate, water and ammonia gas is released. Got it? Water and ammonia gas is released. Actually, it is also a double decomposition reaction. Look here. That is ammonium sulfate plus NaOH. So, it is double decomposition. Ammonium NH4 will go with OH to form, what is that? NH4OH. And Na goes with sulfate to form Na2SO4. Now ammonium hydroxide decomposes to give you ammonia and water. Alright, similarly ammonium sulfate reacts with calcium hydroxide to give you nothing but ammonium hydroxide and calcium sulfate. Clear? You are getting it. So ammonium hydroxide, again it is unstable, it decomposes to give you ammonia and water. Clear? Like ammonium chloride reacts with NaOH to give you sodium chloride, water and ammonia, or ammonium chloride reacts with calcium hydroxide to give you calcium chloride, water and ammonia. Same thing it is. It is a double decomposition reaction. Write it and see that NH4 reacts with OH to give NH4OH, and calcium reacts with chlorine to form calcium chloride. Okay, but as NH4OH is unstable, it decomposes to give you water and ammonia. For that reason, you get the ammonia gas, and water you get it. Are you following what I am saying? Okay, so now next is we are how do we prepare it in the lab, this particular one. So we are having a diagram for it. Now see it here. we have taken a round bottom flask and the flask is kept in an inclined manner. Now why it is kept in an inclined manner? Because water which is being produced, it will not trickle back to the hot flask. Alright, because in the reaction you have seen it I have shown you the reactions there, the equations there. You have seen it that water is being produced in this particular reaction. So water will not trickle back to the hot flask, due to which the hot flask may crack. To prevent that, we have kept the round bottom flask in an inclined manner. Got it? So we have taken there, what is that? We have taken sal ammoniac, that is ammonium chloride, and alkali we have taken it. Let us say calcium hydroxide, we will take it and we will be heating it. On heating, you will be getting the ammonia gas. The ammonia gas is being passed through the drying agent, that is calcium oxide. Alright, drying agent, the calcium oxide, and it is being collected by which method? By downward displacement of air, isn't it? This method is what? Downward displacement of air will come down and ammonia will go up. Why? Because ammonia is lighter than air. How ammonia is lighter than air? I told you how to calculate the density. Molecular weight of ammonia is 17. Nitrogen 14, hydrogen 3, 14 plus 3, 17. 17 divided by 2, because vapor density is equal to molecular weight by 2. So 17 by 2, how much it is? 8.5. Isn't it? Whereas the vapor density of air is 14.4. Air's vapor density is 14.4 and ammonia's vapor density we got it as 8.5. 17 by 2, molecular weight is 17. So hence, for that particular purpose, ammonia is lighter than air. For that particular purpose, it is being collected by downward displacement of air. Downward displacement of air. Not only this reason, but also ammonia is highly soluble in water. Highly. You have read it in the previous chapter that HCl was highly soluble in water. 452 volumes of HCl was soluble in 1 volume of water. Here you will find 702 volumes of ammonia is soluble in 1 volume of water. That means 702 liters of ammonia is soluble in 1 liter of water. Got it? Highly soluble. For that particular purpose, in the beginning itself I said, for that reason it was called as an alkaline air, because due to its basic nature and due to its high solubility. Alright, so hence what you find is that ammonia is being collected by the downward displacement of air, because two reasons. Ammonia is highly soluble in water and ammonia is being lighter than air. For that reason it is being collected by downward displacement of air. So we are passing the gas through a drying agent, that is calcium oxide. See, we are having several drying agents, isn't it? We are having several drying agents, but why do we take calcium oxide as a drying agent? Several drying agent means we are having sulfuric acid concentrated, we are having phosphorus pentoxide, we are having anhydrous calcium chloride. Why do we take calcium oxide only? The main reason is that all these substances which I named you, concentrated sulfuric acid, phosphorus pentoxide, anhydrous calcium chloride, they react with ammonia. Alright, they react. What we want, drying agent should not react with the gas. It should dry the gas only, but they react with ammonia. Alright? But calcium oxide, as it is basic in nature, ammonia is also basic in nature. So hence they do not react with one another. Calcium oxide is basic in nature. Quick line, calcium oxide is basic in nature and ammonia is also basic in nature. So hence they do not react with one another. Due to this reason, what you find is that ammonia is being collected by passing through the drying agent, that is calcium oxide, by the downward displacement of air. Now, when it reacts, what it happens, you see there, I have given you that ammonia gas, you can see there, ammonia reacts with calm sulfuric acid to give ammonium sulfate. So hence it is not collected by passing through concentrated sulfuric acid, because ammonia is basic, sulfuric acid is acidic. So hence they react with one another. Next, with ammonia, when react with phosphorus pentoxide, it gives ammonium phosphate. Again it reacts, because phosphorus pentoxide is acidic, ammonia is basic. They react with one another. Ammonia reacts with calcium chloride, anhydrous calcium chloride, to give an addition product, that is CaCl2.8NH3. So in all the cases, you can see the reaction I have given you. Ammonia reacts with calcium chloride, ammonia reacts with phosphorus pentoxide, ammonia reacts with concentrated sulfuric acid. Alright, but ammonia has got no reaction with calcium oxide, as both are basic in nature. Hence it is collected by passing through the drying agent, that is calcium oxide, by the downward displacement of air. Okay. Now the next question is that here during preparations of what you can say this gas ammonia, we are taking calcium hydroxide. Why? Why do we take calcium hydroxide? The reason is that calcium hydroxide is cheap, and unlike other caustic alkalis, it is not deliquescent. Caustic alkalis means sodium hydroxide and potassium hydroxide. You know they are caustic in nature. For that reason, Sodium hydroxide is known as caustic soda and potassium hydroxide is known as caustic potash. But unlike sodium hydroxide and calcium hydroxide, potassium hydroxide, calcium hydroxide is not deliquescent in nature. We can say that. Got it? So, and moreover, it is cheap. For that particular purpose, it is being used. Next is a higher ratio of alkali is being preferred. Of course, you can see in the equation that ammonium chloride and calcium hydroxide is 1:1 ratio. But generally, we take a very higher ratio by weight. Ammonium chloride and calcium hydroxide we take, that is calcium hydroxide is taken as a higher ratio by weight, means more of calcium hydroxide we take it. Understood? Calcium hydroxide by weight more we take. Why? So as to write down this, so as to counteract the loss by sublimation of ammonium chloride. See, ammonium chloride is a sublimable substance. So if you won't take excess of calcium hydroxide, then ammonium chloride will sublime before it gets a chance to react with calcium hydroxide. It will sublime ammonium chloride. Got it? Because ammonium chloride we are taking in the solid state, so it will sublime. So prevent that particular sublimation, we are taking calcium hydroxide in the higher ratio, so as to counteract this loss. So that what you can find is that sublimation does not take place, or if it is taking place, a minimum sublimation will take place, and maximum ammonium chloride is being reacting with calcium hydroxide to give ammonia gas. Now next is round bottom flask. I have said you that why it is kept in an inclined position. I have said you that particular thing. And how do we know that the gas jar is filled with ammonia? How do we know that? Very simple. Now in HCl chapter, what I said you bring a glass rod dipped in ammonium solution near the mouth of the gas jar. You'll get dense white foams. Here I will say you take a glass rod dipped in HCl solution, alright, or in conc HCl. You dipped in conc HCl a glass rod and bring it near the mouth of the gas jar containing ammonia. You will see you'll get dense white fumes. Alright, what I said, you take a glass rod dipped in HCl solution or in conc HCl and bring it near the mouth of the gas jar containing ammonia. Don't dip it inside, bring it near the mouth. You will find that you will get dense white fumes, proving that the gas jar is being filled with ammonia. In this way, we prepare what you can say ammonia in the lab from what you can say base. That is, either we use calcium hydroxide. Better to use calcium hydroxide, is told you the reason. Don't use sodium or potassium. Theoretically it is possible, practically we never take it, and we take sal ammoniac and we prepare it. So I told you everything there, that ammonia, how it is being collected, how it is being passed, why you are taking higher ratio of calcium hydroxide, why it is preferred, why ammonium nitrate is not preferred, because it is highly explosive, it is highly unstable in nature. Got it? And for that reason we don't take all these things. Understood? Now next, after that, it is collected by the downward displacement of air. Yes, everything I have told you upon this particular slide. The next slide we will see it. Thank you very much.